The Mystery of the Moving Stones, Investigating the Self-Moving Rocks of Death Valley, California. In the vast and desolate expanse of Death Valley, California, an enigmatic phenomenon has perplexed scientists and visitors for decades. Known as sailing stones, sliding rocks, or moving stones, these rocks, some weighing hundreds of pounds, mysteriously move across the flat, dry surface of the racetrack playa, leaving behind long, winding tracks. This phenomenon presents a captivating natural puzzle, combining elements of geology, meteorology, and physics, and has sparked significant scientific interest and numerous theories attempting to explain it. The racetrack playa, where these stones move, is a dry lake bed nestled in the mountains of Death Valley National Park. It is exceptionally flat and level, with the northern end only about 1.5 inches higher than the southern end. The playa is covered with a very thin layer of mud, clay, and silt. This unique setting is crucial for the phenomenon, as it provides the ideal conditions for the stones to move. Historically, many hypotheses have been proposed to explain this strange movement. Initially, some speculated that strong winds, possibly combined with the slick surface of the playa after rain, could be responsible for pushing the stones. Others proposed more complex theories involving ice formation around the stones that could reduce friction and allow them to slide when nudged by winds. However, for many years, these theories remained largely speculative due to the lack of direct observation of the phenomenon in action. The stone's movement was not observed in real time, and this elusiveness added to the mystery. The breakthrough in understanding this phenomenon came relatively recently, with a combination of modern technology and dedicated research. In 2014, a research team led by Richard Norris of the Scripps Institution of Oceanography and James Norris of Interwolf used GPS tracking devices and time-lapse photography to study the movement of the rocks. Their research provided conclusive evidence supporting the ice-mediated hypothesis. The Norris team discovered that the movement of the stones occurred under a specific set of winter conditions. First, the playa fills with a shallow layer of water, which is an uncommon event, requiring a perfect combination of rainfall and snowmelt. Overnight, as temperatures plummet, this water freezes into thin sheets of ice. Then, as the morning sun warms the playa, the ice begins to melt and break up into large floating panels. Light winds then drive these ice sheets, along with the stones embedded in them, across the slippery mud surface of the playa. This process can occur over several days, with stones moving several meters per day. This explanation aligns with the observations that the stones' trails are often parallel and of similar length, suggesting they're the result of a common force acting uniformly. Additionally, the Norris team noted that stones with rough bottoms leave straight tracks, while those with smooth bottoms tend to wander. While this research has provided significant insight into the mechanics of the moving stones, some aspects of the phenomenon remain unexplained. For instance, the conditions required for stone movement are rare and delicate, making it challenging to predict and observe future movements. Furthermore, the interplay of the various factors, water depth, ice thickness, wind speed, and the physical characteristics of the stones themselves, creates a complex dynamic that is still not entirely understood. The sailing stones of Death Valley stand as a striking example of the subtle and intricate ways in which natural forces can interact to produce remarkable phenomena. This mystery, now largely unraveled, reminds us of the persistent curiosity and ingenuity of scientific inquiry. It highlights the importance of direct observation and innovative use of technology in understanding the natural world. As investigations continue, the moving stones of Death Valley will undoubtedly provide further insights into the intricate balance of geological and meteorological processes at play in this unique and harsh environment.